All right, let's talk about something we see literally every single day, but maybe don't really think about. Light. It's everywhere, right? But its true nature, well, that's one of the most fascinating and honestly strangest puzzles in all of science. So let's dive in. So let's just start with the biggest question of all, the one that scientists argued about for centuries. Is light a wave? Like a ripple spreading across a pond? Or is it a stream of tiny little bullets, these individual particles? What do you think? Well, the answer, it's a little weird. And that weirdness brings us to our first big idea, light's absolutely bizarre dual identity. See, it just refuses to fit neatly into one box, and that's exactly what makes it so important to how we understand the universe. They call it wave-particle duality. And what's so completely mind-bending about this is that light isn't choosing to be one or the other. It's somehow both at the exact same time. How we actually see it, whether it acts like a wave or a particle, totally depends on how we set up an experiment to look at it. It's a cornerstone of quantum physics, and it really messes with our whole idea of a simple fixed reality. Okay, so light's identity is strange. We've established that. But what does it do? Well, it travels. And it travels faster than anything else in the entire universe. It is the ultimate cosmic marathon runner, the absolute speedster. Just look at that number. Nearly 300,000 kilometers per second. That's it. That's the universe's hard speed limit. Nothing with mass can ever reach it. It's one of the fundamental rules of the game. And to put that into perspective for all of us, that's 299,792 kilometers per second, or if you're thinking in miles, that's a staggering 186,000 miles every single second. At that speed, you could zip around the entire Earth more than 7 times in the blink of an eye. Just incredible. But here's the thing, even at that insane speed, the universe is just so unbelievably vast that light still takes time to get places. The sunlight hitting you right now, it actually left the sun 8 minutes and 20 seconds ago to travel the 150 million kilometers or 93 million miles to get here. Think about that. If the sun were to just disappear right now, we wouldn't have a clue for over 8 minutes. And this is where it gets really cool. It means when you look up at the stars at night, you're literally looking into the past. The light from our nearest star system, Alpha Centauri, is over 4 years old by the time it reaches us. And the light from the Andromeda Galaxy? That light is 2.5 million years old. You're not seeing those stars as they are today. You're seeing them as they were when that light first began its journey. Stargazing is quite literally time travel. So, let's bring our focus back from the depths of space to our own planet. Because when all that ancient light finally gets here, it interacts with our world to create some absolutely magical effects. One of the most interesting things light does is bend. Out in the vacuum of space, it travels in a perfectly straight line. But the moment it hits something different, like our atmosphere or a glass of water, it slows down a tiny bit and changes direction. This is called refraction, and it's the beautiful secret behind rainbows and the way a diamond sparkles. And of course, rainbows are all about color. Visible light is really a whole spectrum of different wavelengths, and our brains are just amazing translators that interpret those wavelengths as all the colors we see. It's kind of wild to think that our entire vibrant world, with its estimated 10 million different colors, is all created by this simple interaction between light and our eyes. Speaking of colors, here's a fun little fact for you. Black isn't actually a color in the same way that red or blue are. An object looks black to us when it absorbs all the different wavelengths of light that hit it, so nothing gets reflected back to our eye. So, scientifically speaking, black is just the absence of light. We've seen how strange and beautiful light is. But to really truly appreciate it, let's think about the extremes for a second. What happens when there's way too much light or none at all? Remember, light is pure energy, and if you concentrate a ton of it in one spot, it can get incredibly powerful. The world's brightest flashlights blast out over 100,000 lumens. I mean, that's so intense, it can literally burn things and cause permanent blindness. It's a pretty stark reminder that light isn't just a passive thing we see with, it's a real fundamental force. But as powerful as concentrated light can be, its absence, well, that would be far more catastrophic. So what would actually happen if the sun's light just stopped coming? Well, within just a week, the average temperature across the entire globe would plummet. Without the sun's constant energy warming us, the Earth would become a frozen ice ball. The average temperature would drop to minus 270 degrees Celsius or minus 454 degrees Fahrenheit. That is almost as cold as deep space. Our entire world, all life, depends completely on that 8-minute journey of light from our star. So light is a particle and a wave. It's a time machine. It's the source of every color we see, and the reason our planet is alive. Every single photon of light that reaches your eye has traveled across space and time, and each one carries a message from the past. And as we build more and more powerful telescopes to catch even older, fainter light from the dawn of time, you just have to wonder, what other secrets about the universe is it waiting to tell us?